A C concentration drug we are taking in a cuvette which is having a path length of B. So an intense light P0 is coming in and some amount is absorbed and P is the transmitted light. So what is transmittance? P by P0. What is absorbance? I told we have to take what the log scale, isn't it? So log the reverse P0 by P is the absorbance. So we can derive Beer-Lambert's law like this. So we are going to derive Beer-Lambert's law by this. So just I am taking, as I told, this is the total drug concentration. I am just taking an integral part. Okay, integral part. So here what happens, the light is coming in and here the light is absorbed based on the number of particles in this integral area. So I'm going to integrate it. Suppose Px is the total light in this total cuvette. Suppose this small light which is absorbed here will be dpx. So integrating dp s by ps, because I am putting minus sign, why? Because light is absorbed, that's why dpx by or px. Okay, the px is the total area and dp is the area, so the light intensity decreasing in this integral part, which is equal to the total surface area, that is the total area is S, and in this small area is ds. Okay, so integrating this, what is the intense light? P0, which is coming to P. So we can integrate P0 to P. I'm putting minus sign because light is getting what? Decreased. So dpx by px, which is equal to where the number of electrons from 0 to n, isn't it? So here the number of electrons is proportional to what? Due to, so now the light intensity which is decreased in the whole area to this integral area, that is the integral area, the light intensity decreases dp and px is the total light intensity which is passing through, which will be proportional to what? The number of electrons in this small area or the integral part, isn't it? This small integral area or what? This number of electrons which is responsible for this absorption. So we are integrating from 0 to n, which is equal, which will be what? The proportionality constant you are changing means you have to add what? A constant, and which is proportional to the number of electrons here, that is dn, isn't it? Which to the total number of electrons or total surface area. Yes. Okay, so ds by ds, we are just changing the ds to what? Which is proportional to the number of electrons in this area. So that's why when you remove the proportionality constant, we are putting a constant and we are putting which is the number, dn is the number of absorbing species in this small area. Okay, so integrating these two, we will be getting to natural logarithm, that is ln p0 by p is equal to a n by s. Okay, so this is the integration. When you integrate this, we are getting minus, because light is getting decreased, that is a minus p0 by p is equal to a n by s. Okay, so what is log p0 by p? Already we have seen log p0 by p is absorbance. So absorbance is equal to a n by, we have changed from natural to log, so we have to use that value 2.303 s. Okay, so log p0 by p is what? Absorbance. Absorbance is equal to what? a n by 2.303 s. So what is this area? Yes, area S can be what? It can be S can be what? Volume by length or volume by breadth. S is actually, the unit is centimeter square because it is area. So volume by breadth is what? Area. So V by V. So we can replace this S with V by V. So A is equal to, or log P0 by P is equal to, we can write like, we can substitute this S with V by V. So we can write A and B by 2.303 V. Is it okay? Now just S is at the denominator, that's why I am writing V by V like this. So A is equal to A and B by 2.303 V. Okay. Or finally, we can say what is N by V? N by V is actually the concentration, isn't it? So the number of particles in a particular volume can be called as concentration. So N by V is what? N by C is actually N by V. So we can write A is equal to A, and this B is there replacing with C. So here we can write A is equal to ABC. When I am representing the concentration in grams per liter, it is this constant is called absorptivity constant. And when I represent in moles per liter, what happens? A is equal to epsilon BC, where epsilon is called molar absorptivity constant. Here it is verum the absorptivity constant. So absorbance is equal to absorptivity into this path length, already shown here, path length, and C is the concentration. So here the Beer told the concentration is proportional to what the decreased light, isn't it? The light intensity decreases with the increasing concentration. That is what Beer proposed. And Lambert proposed it is proportional to the increase in thickness of the medium. So it's C. So that's why these two are coming in this term in the absorbance, and this is the constant. This is how we derived Beer-Lambert's law. I think